Hey, welcome to the next video of the FlapPyBird series. So in this video, we're going to start some coding. What we're going to do in this video is we're going to take this screen, which is relatively high resolution and color, and we're going to shrink it so it's no longer high resolution and it's no longer color. And we're going to do that because then there's less information to feed to the convolutional neural network. Convolutional neural network will run faster, train faster, hopefully work better. So that's our plan. So let's get going. I'm not sure how popular the coding bit is on my channel, really. I think people just like watching the videos. But I always provide chapter headings, so you can always skip over. Anyway, I'm going to do some coding. All right, so the code at the start of this video, we've got two files, flappy.py, which is basically a modified version of what comes in FlapPyBird, and flappyrl is our script that's going to run the reinforce. Right, so we've got a loop over episodes, then we've got a loop over steps. We get the screen buffer, and we need to do something with that in order to get an action. So the action is either we jump or we don't. So it's just a boolean, it's like 0 or 1. Yeah, so I think we should downsize this screen buff. There's probably like ways to do that that don't involve learning. I don't think we want it to learn, but I think we just use an average pooling, but just get rid of the gradient so that it doesn't learn. We're going to do with torch.nograd, and then screenbuff t equal f dot, and then like there should be something like an average pooling or something like that. And we're just trying to like downsize the image, because if the image is too big, it's just going to be really slow to learn, and it's not like we need that huge giant image, I feel. So average pool 2D. What average pool 2D does is it takes like tiles. It takes your image, which is like 300 by 500, and it's going to tile that with tiles whatever size you want. And for each tile, it's going to take the average value of that, the average color of that tile, and replace that entire tile with a single pixel having that average color, so it shrinks the entire image. Before we do that, we should probably grayscale it. How are we going to grayscale it? We could just take a single color like the red or the green or the blue, or we could somehow average over those. I guess we can average over those without doing any sort of networky stuff. Because, so our screen buff t is a torch tensor, right? And if we print the size of it, we can then just use some sort of torch averaging command. So Python flappyrl, that should run, print the size of that tensor, and then crash. Boom. All right, so we're basically going to average over this last dimension. And then we should find a way to print this out so we can see what the resulting image looks like, actually. So screen buff t equals screen buff t. Is there an average? I don't know. Would we even find out from here? Mean. Torch.mean. Let's just try this. Import torch. And then b equal torch.ran23. Alright, so it is, yeah, so 0.63 seems like the average of this, and 2255 seems like the average of this. Alright, so all we're going to have to do is, so in our case, we want to average over this dimension, and we can throw away this dimension actually, I think, because we just want to recreate it beforehand as the channel anyway. Alright, so we're just going to do mean dim equal -1. And then let's find a way to save that. So to save that out, we're going to use pill. So pillow is sort of a modern version of pill, and pill is some sort of image library. We've already got a pillow. Won't this be like pillow? I'm not sure. And then let's have a method save image, and we're going to take a tensor, and then this is a torch.tensor. And we're going to take a file path, which is a string, and we're going to do, right, so first we're going to do im equal image dot from array, and then obviously this tensor we have to convert it into numpy, and then we're going to do im.save file path. Alright, so let's try that with the original image. So save image, let's do it without the save image, foo.png, screen buff t. Let's run that, see if that works. So let's check that out. Yeah, whatever. Alright, so foo.png. Okay, so it's the wrong way in various ways. So we need to rotate it. So we need to transpose like the first two dimensions, and we're just going to have to flip it somehow. So we're going to, so tensor equal tensor. So we want to flip the dimensions, but we're also going to have to flip it horizontally maybe somehow. Oh no, that's fine. Alright, so we can output the image, and now what we're going to do is we're going to grayscale it. So we're going to do screen buff t dot mean, and then I suppose we should do keep dim. Alright, so this assumes the channel is the last dimension, right? What happens if we only provide 2 dimensions? I don't know. Well, let's try it. So screen buff t now only has 2 dimensions because we got rid of the last one. So foo2 mean could not infer output d type. Input d type must be a floating point. Alright, so that's because our screen buff currently is integers. So let's divide screen buff by 255 to turn it into floats. Then after getting the mean, we're going to multiply it by 255, or maybe by 256. Maybe this should be divided by 255. And then we're going to convert it back into long. So basically our image currently is integers. But in order to do mean, it has to be floats. So we can get floats by dividing by 255, which will automatically turn it into, so this should be, wait, what? Instead of converting this into a long, we're going to convert it into, what is it, a byte? I'm not sure. It might not be a byte. I think a byte is signed, so maybe it should be like a char. I know that's right. Alright, so open foo2. Okay, we've got grayscale. Cool, and then we're going to shrink that. It'd be good to get a picture with the pipes, actually. I wonder what step num that is. I guess we could just record every step num. Let's not record the original. And let's put it in a folder called like temp step num. So we're going to make a folder temp. So we're not going to do this, and we're only going to save like every few steps. So if step num percent, like maybe once a second, something like this. So let's try that. So we're just going to run it for a bit, and so that we've got some pipes, and then we'll look at the picture when we've got pipes. All right, cool. All right, so if we look in temp, so let's open temp 90. So this should have some pipes in it. Where's the bird? Okay, pipes and bird. I think that's fine. And then we want to downsize the resolution. So to downsize the resolution, we're just going to use like an average pooling. So we have to import the f. So import torch.nn.functional as f. And how much are we going to downsize it? So we're going to try like different downsizes and see what works. Let's try like, I don't know, like 8 times. Is that too aggressive? Probably. So we can unsqueeze. So at the moment, this is like it's height and width, and we want to add a C here of dimension 1 for the channels. So we're just going to unsqueeze like the 0th channel. And it just means that the dimensions, I guess we can print out that. We can print out this size actually, just to show what this does. Right, so our image to start with 288, 512, 3 colors. Okay, this is the height actually, and then this is the width. And then after doing the averaging, it's 288 by 512, and then we unsqueeze, so now we've got this first dimension of size 1. Oh, the average pooling might want a batch size, so we might need to unsqueeze again. Oh, well, that's the other issue. Alright, so we should divide this by 255. So you know what, let's put this multiplied by 256.by. This is coming in as a float tensor, and we're going to have to convert that into bytes. So we're going to do tensor equal tensor times 256 and then dot byte. Alright. Okay, so save float image. So this is going to be save float image. So we're no longer going to do this times 256.byte because that's handled by this save float image function. And so that means now screen buff T is floats, which means we should be able to do the average pooling just fine. Cannot handle this delta U1, where are we? Line 14, save flow image. So print tensor.size, tensor.size, and tensor.dtype. So torch.uint8. The size is odd. I think we need a batch size. So we're going to do another unsqueeze. So we're going to have a batch size of 1. And then when we print this image, we're only going to print. So we're going to take the first thing in the batch size is 1, and we're going to take the image plane, well, there's only one image plane, and we're going to save that. See if that works. Alright, so that's saving out. So let's open temp and 90. Alright. This is pretty low resolution. We can see where the bird is, we can see where the pipes are, we can see this. I mean, that's pretty aggressive. But I think it's good enough. So we're going to use this. I wonder what the resolution is. Can we find out from here? Oh, from here. It's 38 by 64. 36 by 64. Yeah, that's great. Let's use this. Hey, so that's it for this video. In the next video, what we're going to look at is taking this image and then stacking it into a stack of this frame with the previous frames, and then in the video after that, we can then feed that into a convolutional neural network. So see you there, hopefully.